Well, good morning, ladies and gentlemen. Okay, taking up numbers 6 to 10 on your probability review. So the first one gave us two spinners, one labeled 1 to 3, the other one labeled 2 to 4, and we had to multiply them all together. So you can see I've made a little table to show the possible outcomes. And then it said to list the probabilities of getting each of the numbers. So you can see probability of getting a 2 is favorable outcomes over total possible outcomes. There's only one 2 out of a 9 total. So that's 1 over 9. Same with the probability of getting a 3. For probability of getting a 4, there are two 4s. So it's two favorable outcomes over a total of 9. And then same with the 6, there's two of them. There's only one 9 and then a 12. And it looks like I forgot to sneak 8 in there, but that would be 1 over 9 as well. Okay. So part C asked us which products are equally likely. So the probability of getting a 2, 3, 8, 9, or 12 is all the same because it's 1 over 9. And then the probability of getting a 4 or a 6 would be equal as each other as well because they came up as 2 over 9. D said probability of getting a perfect square. Well, the two perfect square answers we had were 4 or 9. And there's two of those, so it would be 2 over 9 or 22%. E said probability of getting an answer that's less than 10. So that's all our answers from 2 to 9. Oh, excuse me. And that's all of them other than 1, because there's only one 12 in there. Okay. So it'd be 8 over 9 or 89%. Number 7 read, Irina and Rihanna share a dirt bike. They toss a coin to decide who's going to ride first each day. Irina picks heads the first day, then tails, tails. And they wanted a tree diagram to show all the possible outcomes. And then it said, what's the probability of Irina riding 3 days in a row first, choosing heads, tails, tails. So again, with a coin flip, there's two possible outcomes. And because they did it for 3 days in a row, we have 3 levels to our tree diagram. And then the fourth column is our possible outcomes. So again, day 1, heads, tails. On day 2, if we got heads on day 1, what could happen? Well, we could get heads, tails. And then you go down here. What if we got tails on day 1? Well, then we could get heads, tails on day 2. And then same thing on day 3, break off each possibility from day 2 to the two possible outcomes, heads, tails, all the way down. And then, as I was explaining in some of the other videos, for your possible outcomes, you just follow the trail to each endpoint. So the first one would be heads, 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 tails, heads, tails, heads, heads, tails, tails. Okay, and we did the same all the way down. And we see that Irina chose heads, tails, tails, so I circled our outcome there. And again, probability, favorable outcomes over total possible. There's only 1 out of a total of 8, so that's our answer. Number 8 said, explain how to simulate the birth of a male or female puppy with each item. And the first one said a coin. Well, that's easy. You can make heads male or tails female or vice versa. It said a dice. Well, dice have 6 choices, so we just need to make it equally likely for each of them. So I chose 1, 2, 3 as male and 4, 5, 6 as female. A spinner, if you're going to make a spinner for it, well, you just make 2 equal sections and then make one side male, one side female. 9 said, according to a news report, 1 out of every 4 computers is defective, and they want to design an experiment to estimate the probability that when 6 new computers are delivered to a store, 3 of them are defective. Okay, so here's the spinner that we made. Because it says 1 out of 4 computers is defective, there's our 1 out of 4 that are defective. And they're delivering 6 computers, so 6 hits or flicks of our little spinner counts as 1 trial. Okay, so to do this experiment to actually predict in real life, you would need to do this 50 to 100 trials. In 100 trials, that means 600 spins. So you'd probably want a small team of people helping you out. Otherwise, you're going to be doing it a lot. And then you would be seeing how often you would get 3 out of the 6 being defective. Then the important point from 8 and 9, this is from 11.3, which is simulations. You want whatever the physical thing that you're using, whether it's coins, dice, or spinners, to have the same number of outcomes as your real life thing. And then, as we saw in 9A, so 4 computers, or sorry, 1 out of 4 computers are defective. And then they said for 6 computers, so that means 6 flicks, 1 trial. So you just have to think of how many times you have to do it. And then, if they're asking you questions on, how many times would you have to do this to get a good answer, we're shooting for fairly high numbers of trials. Like to get really good results, 100 is sort of the minimum. If it's, like what would give you a better answer, 50 or 5, well, choose 50. Okay, number 10, talking about odds in favor and odds against. So they said they had dice and they rolled the 2 of them and then they subtracted the numbers. So here's all our possible outcomes for subtracting the numbers. 1 minus 1 is 1. 2 subtract 1 is 1, 3 subtract 1, so on and so forth. Okay? So then it said odds in favor of getting a 1. So odds in favor, and again, with any of these where you're calculating probability, odds in favor, odds against, always write the formula down first. It makes such a difference. And then go hunting. So odds in favor of getting a 1. For favorable outcomes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 favorable outcomes. We have 36 possibilities here. So if we've taken 10 favorable outcomes out, that means we've got 26 left. Drop into lowest terms, 5 over 13. And again, with odds, a lot of times these can be shown in ratio form. So if you see an answer like this, that's fine as well. It means the exact same thing. This one said odds in favor of anything larger than a 3. So we're looking at answers of 4 and 5. So there's 1, 2, 3 here, 4, 5, and 6 there. So 6 out of 30 would be reduced down to 1 over 5 or 1 to 5. For B, it's odds against an odd number. So what I did was go hunt down all the odd numbers, counted them up. I got 18 of them. And then the unfavorable outcomes is going to be 18 as well, reduced down. It's 1 over 1, or in ratio form, 1 to 1. Odds against a 5. So I went and I counted, all the 5s, all 2 of them. There's my favorable outcomes. And then I know if there's 36 outcomes, I've taken 2 out, there's 34 left. So it's 34 over 2, reduced down to lowest terms, 17 to 1. Okay? So number 11 said probability of Anna hitting a home run is 25%. What are the odds against Anna hitting a home run? And you had an assessment focus like this. So probability of a home run, favorable outcomes over total possible outcomes, they told us is 25%. So what I've done is chosen numbers that would give me 25%. Didn't have to be 1 over 4. I could have put it as 25 over 100. It's up to you. Okay, but just get some numbers in there so that you have a number representing favorable and a number representing total possible. And then write down your formula for odds against. So odds against a home run, because it's odds against, unfavorable is on top, favorable outcomes on the bottom. So favorable outcomes, we already know the numbers for that. It's right there. It's the same number. So I filled in my favorable outcomes. I know my total possible is 4. So if favorable is here, how many are unfavorable? Well, I've taken 1 out of this. It's there. So there's 3 left over. So the answer is 3 over 1, or again in ratio format, 3 to 1. That's it. So you have a test tomorrow, Wednesday, and it's only open for 1 day and then it gets closed. So please make sure you're ready for it. And then that's going to be it for probability. Okay, you know how to get in touch if you need anything. Bye for now.